Okay, we have listed below the number of years that archbishops and monarchs in a certain country lived after their election or coronation. We're going to treat the values as simple random samples of a large population. We're going to use the 10% significance level to test the claim that the mean longevity for archbishops is less than the mean of monarchs after coronation. Complete A and B. All measurements are in years. Okay, so the first thing I'm going to do here is I'm going to open up my data and I'm going to copy it to clipboard so then I can do what I want with it here in a few minutes. Okay. Now you'll notice here the archbishops do like kind of where there are more archbishops and monarchs. We don't have equal data sets. So use a 10% significance level to test the claim that the longevity for archbishops, which we're considering sample 1, is less than sample 2, the monarchs. So remember the null is always equal, so I know that A and C aren't right, so it has to be B or D, and I want less than, so there's D. Now I'm going to show you how to do this in StatCrunch. So I am going to come over here. You would want to go to Course Home, and then you're going to click on StatCrunch. Mine, then I think I just put an intermediate one, and then open StatCrunch, and it looks like this. And then I'm going to copy my data into that, and I just use Control-V on my keyboard. Okay, then you want to go up to Stat. I want to go to T-Stats, to sample with data. Okay. And sample 1 is in various 1, sample 2 is in variable 2. Okay, we are not going to click pool variances. We are going to click this here, this hypothesis test. We want that. We want less than. Okay, that's what we were testing. That's one value. Now I'm going to compute this. Here's the issue though. This p-value is not right because it did this at 95, and as far as I know, there isn't a way to change it. There probably is. I don't know. But I'm going to write this down, and then I'm just going to look up the critical value to compare. So negative 2.50. Come in. Negative 2.50. And then when we look at our data, too many screens. Where'd my data go? Where'd my StatCrunch go? There it is. So I have 12 values here. So that's my smaller one. So I'm going to use DF of 11. I have 10% and one tail. So they're 1.36. So I am going to reject because I am well less than that. So I'm going to reject the null. There is sufficient evidence to support the claim that archbishops have a lower mean longevity than monarchs. Now, we're going to then run a confidence interval, and StatCrunch will do that as well. Exit out of this. Go up here, and I'm going to go here again to T-Stats, to sample, and data. And again, I'm going to tell it variable 1 and variable 2. Now I'm going to click on this. Now this I can change, okay? And so I had a one-sided test that had 10%. So I need 10% each. So I actually need to run an 80% confidence interval because I need 10% in each side. Now there are more stuff down here, so you can look through this because these might be cool options as you're looking for your project. And compute. So then my goes from negative 4.6, it's going to 4.70, okay. So I have way too many screens. So negative 4.70 to negative 1.47. Okay, and does this, yes, it does support the test because it only contains negative values, so it's saying less than as well. Oh, only negative values. What did yes, only negative. Okay, hold a second. What did I click wrong? Does the confidence? Yes, because the confidence only negative, okay. Reject. Okay, hold a second. What's it telling me is wrong? Hold on a second. That was right, that was right, that was right. Oh, because I didn't round far enough. Okay, I'm like, they're right. I couldn't even have made an arithmetic mistake. I was copying stuff. I didn't read the directions. That's what I get for doing it in videos. But that's the only thing going on here. That's the reason at this point I was frustrated. You can see here that's exactly what I had. I just didn't round there. I over-rounded. I got too excited because I was 2 and 3. I don't like it when they change it. But anyways, you can see that StatCrunch does this really slick. The one thing to be careful of, though, with the null hypothesis test, though, is that you can't trust that p-value unless you are at 95%, and they will move it around. So you will need to look up the critical value, just like we've been doing for all the others, and compare them. So that's kind of the caveat for that.